Hello everyone, welcome to the Python programming course. In the previous lecture, we learned how to use list, which is a very important data structure in Python. We learned how to modify list, how to create list, how to sort list, and how to use methods like add and remove on list. We also learned about indexing and slicing. In this lecture, we will learn about another data structures, which are lists, which are sets and tuples. Before learning what a tuple is, let's first understand why Python introduced tuples. Imagine you are building a student management system in which we have student details, name, roll number and date of birth. Now which of these values should never change? Roll number and date of birth. These values are permanent. If we accidentally change them, the information becomes incorrect. So instead of using a list, we store this data in a tuple because tuples cannot be modified after they are created. Moving to the definition, a tuple is an ordered collection of elements that cannot be changed after it is created. So a tuple is an ordered collection which is immutable and stores multiple values. Ordered. Ordered means the elements keep their positions. Immutable means cannot be changed. Once a tuple is created, we cannot add elements, we can't remove elements, and we can't replace elements. For example, your Aadhaar card number identifies you uniquely. It should never be modified accidentally. A tuple is useful for storing such fixed informations. Now we will closely look at the characteristics of tuple. The very first characteristic of tuple is that it is ordered. That means elements have a fixed position. Next characteristics of tuple is that it is immutable, which means Python prevents changes to a tuple elements. This means cannot be changed. Third characteristics is duplicates. A tuple allows duplicate values to exist. Next characteristic of tuple is multiple data type. Similar to list, tuple can contain strings, float, boolean values and even other tuples. Values of multiple data types. After understanding the characteristics of tuple, let's quickly look how tuple is different from a list. Firstly, a list is represented by square brackets, where a tuple is represented by simple or say circular brackets. A tuple is immutable, whereas a list is mutable. A tuple cannot add remove elements. While a list can add and remove elements. Tuples are faster and lists are slower in comparison to each other. Tuple is best for fixed value, while a list is best for changing data. Now we will look at the syntax of tuple. Firstly, to define a tuple, we will define the name of the tuple. Say I have a tuple named student and I want to store values as a name, Rahul, age, and city in this. Say I'm writing Delhi here. So this is how we create a tuple. Now tell me this. If I write t equals to 10, I have a single value in this. Is it a tuple? No. Python doesn't treat it as a tuple. This is not a tuple. Python will treat it as a integer. But if I write p dash say equals to 10 comma and then close, now this is a tuple. This comma after the value tells Python that this is a tuple containing only one element. We can also create an empty tuple like empty equals to. We will not assign any value to this. So now we understand what tuples are and why they are useful for storing data that should not change. But just because tuples are immutable doesn't mean they are difficult to work with. We can still access elements using indexing, slicing, loop through them, and apply several built-in functions. In the next part, we will explore tuple operations. In the previous part, we learned that tuples are ordered collections of data that cannot be modified after creation. Now a common question is, if we cannot modify a tuple, what can we actually do with it? The answer is a lot. We can access elements, slice tuples, loop through them, check whether an item exists, pack and unpack values, and use several useful built-in functions. So firstly, we will understand indexing in tuple. Similar to list and strings, indexing means accessing an element using its position. Since tuples are ordered, every element has an index. For example, I create a tuple named fruits and I store values as Now apple is at index 0, banana at index 1, index 2 and index 3, and we can also have negative indexing, that is -1, -2, -3 and -4. Then we have the next topic, which is tuple slicing. Tuple slicing is exactly similar to slicing in list. Here slicing. Tuple slicing means extracting a portion of a tuple. And the syntax is, firstly we will write the tuple name, and in the square brackets firstly we will write the starting index, then ending index, and then step index. Then the next topic which you are going to cover is transversing a tuple. Transversing means visiting every element one by one. For that we have two ways. Firstly, we can use for loop, which is an easier approach. Otherwise, we can use while loop. While loop offers more control over a tuple. After transversing, we will learn about tuple packing. Tuple packing means storing multiple values inside a single tuple. For example, I create a tuple 10, 20, 30. Now several individual values are packed together in one tuple. The next, similar to opposite to tuple packing, we have tuple unpacking. Tuple unpacking means assigning tuple elements to separate variables. Instead of accessing elements one by one using indexes, Python can directly assign them the variables. The next topic is membership operators. Membership operators checks whether an element exists or not. Checks whether an element exists or not. For that, we have the in operator. And opposite to in, we also have not in operator. Then we have some built-in functions. The very first function is length function. Length functions returns the total number of elements in a list in a tuple. After length we have max function, which returns the maximum value in a tuple. Opposite to maximum we also have min function, which returns the minimum value in a tuple. And then we have sum function, which returns the sum of the elements in the tuple. We also have some tuple methods. Firstly, we have the count method, which count how many times the element appears in the tuple. Then we have the index, which returns the index of an element in a tuple. So these were all about the built-in functions and methods in a tuple. Now we have explored tuples in detail and seen how useful they are for storing fixed data. But what if your goal is to do something different? Suppose you don't care about the order of elements and you want to make sure that there are no duplicate values. That's where sets come in, which we will cover in the next part. So far in Python we have learned about list and tuple. Lists are useful when data changes frequently. Tuples are useful when data should remain fixed. But now imagine a different problem. Suppose a website records visitors and one person visits the website 5 times. If we store every visit in the list, the same person's name appears again and again. But what if we only want a unique visitor? This is where sets becomes useful. Now what is a set? A set is an unordered collection of unique elements. A set can store multiple values together just like a list or a tuple. Every element appears only once, and if you try to add same value again, Python ignores it. A set does not maintain the order of elements. That means an element may appear in a different order than you entered them. Now we will quickly look at the characteristics of sets. The very first characteristic of set is sets are unordered, which means Python does not guarantee the order of elements in a set. In some Python versions, the output might sometimes look like the same order you insert, but you should never rely on it. A set is still considered unordered. Then, unique elements. In a set, duplicate values are always ignored. Next characteristic is mutable. That means we can change set. We can add new elements, we can remove existing elements, but individual elements themselves must be immutable, like numbers, strings, or tuples. Next characteristic is there is no indexing in sets. Now, how do we create a set? For creating a set, firstly, we will define the set names. For example, I want to create a set of numbers. Then I name a set numbers which is equals to, and we will write our elements in curly braces like 10, 20, 30, 40. This is how we define a set. We can also make an empty set using, if I write A equals to curly braces, then this is an empty set. Now when should we use sets? Sets are used when we have to remove duplicate values. We have to, for example, I have to write email addresses, I have to write tags in social media, I have to write unique product IDs. In those cases, sets are used. But creating a set is the only beginning. Python provides many powerful operations to work with sets. In the next part, we will learn about set methods like add, update, remove, discard, pop, and clear. In the previous part, we learned what sets are and why they are useful for storing unique values. Now let's learn how to work with sets. We will first study built-in methods like add, remove, update, and then we will move on the mathematical operations such as union, intersection, and difference. These operations are extremely useful when comparing groups of data. Firstly, we are going to start with set methods. The very first set method that we have is the add method. Add method is used to add one element to the set. Add method adds only one element, and if the element already exists, nothing changes. After add, we have update method. Update method is used to add multiple elements to a set. Is used to add multiple elements. After the update, we have remove method. Remove method deletes a specific element from a set. Similar to remove, we have discard method. The problem with remove method is, for example, I have a set and the set doesn't contain a value, and if I use the remove function to delete that value, then remove will gives an error. But in case of discard, it is similar to remove, but in case of missing value, it does not produce an error. It does not produce an error. After discard, we have pop method. Pop removes one random element from the set. After pop, we have clear method. The clear method removes every element and leaves the set empty. After set methods, we have set operations also. The very first operation which we have is union. Union means all unique values from both sides. Union takes everything but don't repeat duplicates. For example, I will make a Venn diagram. And I have two sets, set A and set B. Then this set will give me A, union B will give me this area, this whole area. After union, we have intersection. Intersections means the common elements between two sets. Again, I have two sets, set A and set B. And I want to find A intersection B. Then this common area is the intersection area. After intersection, we have difference. Difference means elements present in one set but not in other. It is represented by A minus B. For example, I have this set. We have A and B have B. Then A minus B means this area. After that, we have symmetric difference. Symmetric difference means elements present in either set but not in both. It removes the common elements and keep only the unique values, and it is represented by this sign. Say again, I will take example of A and B. We have set A and set B. Then A symmetric difference B is this area. The area which is unique to both sets. Sets also includes membership operations like in and not in. There's two membership operators similar to tuples and list, in and not in, which works in the similar manner. Set has only one built-in function, which is the length function, which returns the number of elements in the set. Now we have completed tuples and sets. Before moving to the practical coding session, let's compare list, tuple, set side by side. Understanding the difference will help you choose the right data structure for the right problem. In the next and final tablet session, we will summarize everything we have learned with comparison tables, real-world examples, and decision-making tips. Why do we need three data structures? Python provides multiple data collection types because different problems require different solutions. Sometimes you need to change data. Sometimes the data should never change, and sometimes you only care about unique values. Instead of using one data structure for everything, Python gives us specialized tools. Now, what is the difference between list, tuple, and set? If we look at the syntax, list is represented by square brackets, tuple is represented by circular brackets, and set is represented by curly brackets. Lists are ordered, tuples are ordered, but sets are not. Lists are mutable, tuple are not mutable, and sets are mutable. Duplicates. In list, duplicate values are allowed. In tuples, duplicate values are allowed, but in sets, duplicate values are not allowed. Then indexing. We have indexing in list and tuple, but not in sets. We have slicing in list and tuple, but not in sets. And we have add remove methods in list and sets, but not in tuples. Lists are best for dynamic data. Tuples are best for fixed data, while sets are best for unique data. Welcome back everyone. We have completed the theory of tuples. Now it's time to implement every practical using Python. In this session, we will learn how to create tuples, access the elements using indexing and slicing, and explore some useful built-in functions and tuple methods. Firstly, we will create tuples. For that, I will give it a name, say fruits, which is equals to. So this is how we create a tuple. And now I will fill my values in this. Say I want to store apple, banana, and orange. So this is our tuple. I will be printing it. Print. Fruits. There we go. These parentheses are used to create a tuples, and tuples can store multiple values. We can also create tuples with multiple data types. For example, I will create a tuple named student, and I can store a string in it. We can store integer value, we can store a boolean expression, and we can store a float value also. We will be printing this student. A tuple can contain strings, integers, floats, boolean values, and together. Now, for example, I create a tuple named t1 and I store a single value 10 in it. And again, I create another tuple and I store 10 comma in this. So this t1 is not a tuple. This is the int value. If I write comma after this 10 value, then it will become a tuple. For that, if we check the type of t1, it is int, but the type of t2 is tuple. Without a comma, Python treats 10 as an integer. A single element tuple must include a comma. We can also do indexing on tuples. For example, will be using this tuple only. For this tuple, if I write print student, say I give it index 3, then it will print 2. If I give it print student and I give it a negative index, then it will give me the last element, which is also true. Similarly, we can also perform slicing on tuples. Say I write student
1, comma 3, then it will give me two values, 20 and 95.5. Then we have some built-in functions in tuples like length, max, min, and sum. I will be looking at it one by one. Firstly, we'll create a tuple named marks. We will store some values in this. If I print, firstly we'll create a tuple. If I print length of marks, then it will give me the number of elements stored in a tuple. If I print max marks, this will give me the maximum value stored in tuple. And if I use minimum instead of max, then it will give me the minimum value stored in the tuple. And if I write print marks, print some marks, then it will give me the sum of all the values stored in the tuple. Then we have some tuple methods also. If I write print count, print marks.count, say count of 62, then it will give me the number of elements which are 62 in the tuple. And if I write print marks.index, index of say 99, so it will give me the index at which the value 99 is stored. We also learned that tuples are immutable. For that, for example, I create a tuple num and I store three values in 10, 20, and 30. And if I try to update this tuple, say I write num 0 equals to 40, then it will give me an error because tuples are immutable. We can't update the values of the tuple. So in this practical session, we used indexing, slicing, and applied built-in functions and methods on tuples. In the next practical session, we will explore tuple packing, tuple unpacking, transversing tuples using loops, nested loops, and some real-world tuple projects. In the previous session, we learned how to create tuples, access elements using indexing and slicing, and use built-in functions. In this session, we will explore some advanced tuple concepts like packing, unpacking, transversing tuples, nested tuples, and solve practical problems using tuples. Firstly, we will have a look at tuple packing. Say, I create a variable student and store values something like this. Rahul, 92, 5, then we'll write 20, then write 2. And if I try to print this student variable, we will also print the type of the student, this student variable, print type student. So here you can see this, the type of the student variable is a tuple. Python automatically packs multiple values into a tuple. Parentheses are optional while packing. Similar to tuple packing, we have tuple unpacking. To demonstrate tuple unpacking, we will create another tuple named student and we will store three values with this. We will store a string 20 and I will write Delhi here. And if I say name, comma age, comma city is equal to student. Now I will try to fetch the value. If I write print name, so this will give me Rahul. If I try to print, print age, and print city as well. This will give me the respective values. Each each tuple element is assigned to a separate variable. Another example, we will create a tuple of numbers. We have this tuple, and if I write first, comma, and if I write star middle and last equals to num, and if I say print the first value, then it will print 10. If I say print the last value, then it will print 50. But if I say print middle, so this star before the middle will tell Python to automatically include the rest values in the middle variable. So it will return me 20, 30, and 40. We can transverse a tuple using loops also. If I write for I in num, print I. So here we can see for loops works with tuples in the same manner it works with list. We can also transverse this using while loop. If I write while I is less than length of num, print I, print the num, and update the value of I. Firstly, we have to assign a value to I. We have to initialize I equals to 0. Okay, same result. We also have membership operators in tuples as well. If I try to print 10 in num, it will return true. But if I try to print, say, 100 in num, it will return false. Similarly, if I try to write 10 not in num, it will return false. Next, we have nested tuples. Say I create a tuple named students, and inside this tuple, I'm going to create three more tuples. So the outermost parentheses are going to store this inner tuples here. And I'm going to write date of three students here. Rahul, who is 20 years old, Rohit, who is 21 years old, and Aman, who is 18 years old. And if I say print students, it will print like this. Now, if I want to perform indexing on this nested tuple, say I write students at zeroth index, so it will return me the tuple at the zeroth index, which is Rahul 20. And but say if I only want to fetch Rahul in this, what will I do? I will write student 0. So this will give me this Rahul 20, the first tuple. And now I want to fetch the first value of this tuple. So Rahul is at zeroth index in the inner tuple. For that I will write 0. So it will give me Rahul. And if I write 1, then it will give me 20. So in this way, tuples can store other tuples. We will take one more example. Say I want to fetch this 21 here. I want to fetch this 21. For that, I will write students. Firstly, the index of this tuple, So this is at first index. And now inside this tuple, Rohit is at 0th index and 21 is at first index. So I will write 20 in the next set of square brackets. And if I print this, this will give me 21. If I want to use, if I want to transverse this nested tuple using loops, we can do this using a for loop. If I write for name, comma marks in students, print name, then n equals to c, comma hash sign, then marks. So it will give me the values in this manner. Rahul 20, Rohit 21, Aman 18. This is not marks, this is age actually. So in this session, we learned tuple unpacking, looping through tuples, membership operators, and nested tuples. In the next practical session, we will move to sets, where we will learn how to create sets, remove duplicates automatically, and use powerful set methods like add, update, remove, discard, pop, and clear. In this next practical session, we are going to learn about sets. Say I create a set named fruits and I store three values in it, apple, mango, and banana. And if I try to print this, so we have fruits printed in a set format. A set is defined by curly braces. A set can only include unique values, and a set is not ordered. Say I create another set of numbers, and in this number set, I will try to add duplicate values. In this set, I have written 10 two times and 32 times. Now, if I try to print this set, you can see Python automatically detects the duplicates value and deletes them. Next, what we are going to do, we are going to have a look at set methods like add, update, delete, and many more. For that, we will use this set only. I will be using this fruit set. Now, this fruit set has three values, apple, mango, and banana. If I want to add another value, say I want to add orange in this. So I will write fruits dot add, and in the parentheses, I will write orange. And if I try to print it, you can see orange is included in the set. The next method that we have is update method. For example, I have a set of numbers which has only two values, 10 and 20. And now I want to add more values in this particular set. So what will I do? I will write numbers dot update. And in this parenthesis, I will pass a list of numbers which I want to add to the number set. And now I will try to print it. So you can see we have the updated version of our set. Then we have the remove method. If I write fruits, we have this set apple, banana, mango, and orange. And if I want to remove a value from this fruit set, say I want to remove banana from the fruits, then I will write fruits dot remove banana, and if I try to print it, print fruits, you can see banana is deleted from the set. We can also use discard in this. If I write fruits dot discard, food or discard apple, and if I try to print it, you will see apple is also deleted from this set. If I again try to print, if I again try to remove apple from it, see, apple is already deleted. And if I again use the remove method, it will give me an error. But if I use discard method instead of remove, then this will not give me an error. So this is the primary difference between remove and discard method. If we remove an already deleted value from the set, then remove method gives an error, while discard method doesn't give an error. After that, we have pop method. If I write fruits dot pop, then it gives the random value. Then we have the clear method. Say I create numbers variable, set of numbers, which is equals to this. And if I write num, if I want to make this set, convert this number set to an empty set, I will write num dot clear. And then if I try to print this num set, we will have a empty set. So in this session, we learned how to create sets, add, remove elements, check membership, and understood why sets automatically remove duplicate values. In the next session, we will explore powerful mathematical operations like union, intersection, difference, and symmetric difference. So we have learned how to create sets and use methods like add, update, remove, and discard. Now we will explore the real power of sets using mathematical operations such as union, intersection, difference, and symmetric difference. These operations help us compare data efficiently and are commonly used in real-world applications. Firstly, we will create two sets. One is named cricket, which has three names in it. Rahul, I will store three names in it. Rahul, Aman, and Priya. Similarly, we will create another set named football, and in this we will again store three names, which is Priya, Simran, and Rahul. Now I will apply union on this. For that, we will create another variable result, which is equals to cricket dot union football, and then we will print result. So here you can see union combines all unique values and duplicate values are used only once. There is another way to do union, which is we can also write result equals to cricket. This is the sign used for union football. This will give me the same result. The next operation which we have is intersection operation. Intersection returns common values. So if I write common equals to cricket dot intersection football, and then I will print common. So this will give me the common values which are common in both the cells. There is also a shortcut way to write intersection, which is we can use and sign. If I write cricket, this is the sign used for intersection. This will give me the same result. After union and intersection, we have difference. For that, I will create two more sets. A, which has values 1, 2, 3, and 4, and set B has values 3, 4, and 5. 5. So if I print A dot difference B, so this will return the elements that are in A, that the elements that are present in A but not in B. For shortcut, we can print A minus B. This will return the same value. After difference, we have symmetric difference. Symmetric difference will return elements that are present in either set but not in both. For example, in A set I have values 1, 2, 3, and 4. And in set B I have values 3, 4, 5, and 6. If I write print A dot symmetric difference B, so this will give me the values from the both sets, but it will exclude the values which are common in both sets. Here, 3 and 4 are the values present in both sets, so it excludes those values. The shortcut way to print symmetric difference is A power to sign, then B. Then we have subset and superset. Say I have a set A which is equals to 1, 2. And in set B, I have values 1, 2, 3, and 4. If I print A is subset of B, A dot is subset B. And if I print B dot is superset A. So the both values are true. Is subset checks whether all the elements of one set are in another, and is superset checks whether a set contains all the elements of another set. Here, A is a subset of B. That means all the elements of A are present in B. And B is superset of A, which means B contains all those elements which are present in A. We will create another two sets. Say I have 1, 2, and 3 in one set, and in set B I have 4, 5, and 6. And if I say print A dot is disjoint B, so this will return true. Disjoint means both the sets don't have any common value. If if the in this set A has values 1, 2, 3, and set B has values 4, 5, 6, these both sets have no common values. That's why A dot is joint B returns true. So we have successfully completed lecture 6, tuples and sets in Python. In this lecture, we learned what tuples are and why they are immutable, tuple indexing, slicing, packing, unpacking, transversal, and methods, what sets are and why they store only unique values, set methods like add, update, remove, discard, pop, and clear, Mathematical set operations including union, intersection, difference, metric difference, subset, superset, and disjoint sets. And in the next lecture, we will learn one of Python's most powerful data structure, dictionaries.